Good afternoon, lovely audience. Today, I'll be discussing how acaricides commercially used to control varroa mite populations, such as floor mite and diphocal, affect Apis mellifera health and colony functions. While acaricides are critical for mite management, their sublethal effects on honeybee behavior and health can majorly negatively affect colonies as a whole. This defeats the purpose if it is killing the very thing it is made to protect. Now, what are Apis mellifera and why do they matter? Honeybees, or Apis mellifera in scientific terms, are essential pollinators that support agricultural ecosystems globally. However, pollination is not their only role. They are also responsible for providing honey and contributing to biodiversity. Unfortunately, though, honeybee populations are under threat from varroa destructor mites, which transmit many deadly pathogens through the use of hosts. To combat these invaders, farmers and beekeepers turn to a new solution: the use of acaricides. If you are not present in the agricultural community, you may not have heard of these until now. Well, an acaricide is a pesticide used commercially within agricultural communities for the control of mite and tick populations. Some of the most commonly used include comaphos, thymol, and flumethrin. While these chemicals are effective, they leave residue in hive materials such as waxcomb, raising concerns about their sublethal impacts. Now that there is an understanding of the conversation, we come to the central question we aim to address. How do sublethal exposures of commonly used acaricides affect colony function of Apis mellifera in terms of survival, brood development, and behavior? This slide brings attention to data from Gracia et al. 2017, which examines the field efficacy of acaricides against its target, varroa destructor. The study tested an array of treatments, including comaphos and thymol, to determine their impact on mite mortality and colony health. The results showed that while the treatments effectively reduced mite infestations, they left large amounts of residue alongside it within wax and other hive materials. For example, thymol was shown to have a high mortality rate amongst mites, nearly 90%. Can you believe that? But the residues also majorly altered worker behavior and brood development. This raises the question among the agricultural community of how to keep this efficiency while minimizing the damages done to colonies. Next, we consider a review by Dinois et al. 2021 regarding the sublethal effects of environmental contaminants, acaricides included, and their effects on colony behavioral function. This study ultimately showed that acaricides like flumethrin and comaphos impair foraging and communication behaviors among worker bees greatly. Sublethal exposure disrupts the olfactory system of those who come in contact with it, and as a result, increased difficulty in foraging for food. This study also highlights the gap in knowledge about long-term colony effects, emphasizing the importance of further research into sustainable pest management. And finally, we examine the impacts of acaricide use on developing broods within colonies, as seen in a 2021 study from Environmental Toxicology and Chemistry. Now, within this study, the data shows that colonies with higher levels of comaphos residue in beeswax foundations found a 25 to 30% increase in larval mortality rates as compared to the control group. So, this decline in brood viability is a direct representation of the threat to colony regeneration and long-term sustainability. The findings emphasize the need to reduce the levels of comaphos residue in hive materials to protect future generations of honeybees. So, to summarize, acaricides such as flumethrin and comaphos have sublethal effects on Apis mellifera and their livelihoods as colonies. With each prolonged use, the risk of reduced survival rates, impaired foraging behaviors, and compromised brood development increases. These findings shine a light on the need to begin implementing more restricted acaricide use and residue management strategies for the sake of our honeybee population. Everything having been said, why does any of this matter? Well, honeybee health is crucial to a beautiful and thriving ecosystem. They are the backbone of agriculture, and without them, the world would look just significantly more bleak. With that, understanding the impacts of acaricides and preventative measures allows us to develop safer mite management techniques, ensuring healthy bee populations. This is all crucial for sustainable practices for hive management. Now, last but not least, here are all of the references cited throughout this presentation. Each provides essential data and insights toward building a comprehensive understanding of acaricides and their effects on Apis mellifera colonies and Varroa destructor. Thank you for your time and attention.